Hello, today we will to present topic of encouraging the prevention of illegal online gambling to social network analysis. Agenda for today will cover introduction, motivation, social media graph, architecture, proposed solution, interpretation, summary, and finally introducing our team member. From the picture, you can see that during COVID period, online gambling has more than 10 billion Thai baht in circulation. And you can see that channel of online gambling advertisement are most for is Facebook. Importantly, more than 3.6 million young people want to play online gambling up to 28%. There are examples of Facebook ads. The picture is example of comment with bot, and like picture is fake page on Facebook. Then with both picture make our know too difficult to for detect whether it is bot or person account. Our motivation in this topic are reducing gambling addiction, enhance platform responsibility, and protect vulnerable groups.
Okay, the challenge of handling the huge amount of data on Facebook. In Thailand, as of 2024, Facebook had about 58 million users. Around 50% is women and around 49% is men. Every day, there are around 26,000 new users join this platform. With so much activity, there are three main challenges we face. One, scalability of data. As data grows, the number of moderators remain the same, making it harder to manage effectively. Two, identify key actors. With a large dataset comes a lot of noise, making it difficult to pinpoint the key players spreading gambling content. Three, delay processing and analysis. Information spread quickly, but slow processing make it hard to prevent harmful activity in time. That's why we need advanced tools like social network analysis to manage the data effectively, identify key actors, and detect this illegal activity. This diagram represents the key components of Facebook that we analyze as part of our study. Each node and connection here shows how user interacts with the post, page, group, and each other. For example, user can create posts, like, share, follow, comment, or even mention others. This interaction form a network of relationships that we need to collect and analyze. By gathering data on this interaction, we can build a social graph that help us identify patterns, such as which accounts are central or to spreading content. This is critical for understanding and address harmful activity on the platform. This is an example of how we analyze the interaction from the previous slide. In the method data table, we filter action related to gambling content. For instance, user 1 comment on post 1 by user 5, user 2 share post 2, and user 3 create post. For the comment metric table, we focus on comment only. We filter the comment and convert them into a metric table. Each row and column represent a user, and the value show whether one user interact with another. For example, user 1 interact with both user 2 and user 3, but user 3 has no interaction with others. This structure allows us to map and analyze social network or social media relationship to identify the pattern of harmful content spread, like online illegal gambling. This is an architecture of this project. We start with a data source. Here, we use synthetic data to simulate realistic scenario for analysis. This data is then structured into and interaction table, which organize user actions such as comment, share, and like. From here, we extract three key metrics: the comment metric for analyzing user comment, the share metric for tracking content sharing, and the like metric to capture user engagement through like. Next, we apply social network analysis concept, which include digitory to measure the number of connections each node has, helping identify highly active user. Betweenness centrality to pinpoint the node that act as a bridge within the network. Crossness centrality to to evaluate how quickly information can spread to a node. And eigenvector centrality to highlight influential nodes that are connected to other influential nodes. These insights are fed into feature engineering, which prepare the data for supervised learning. The results are visualized and analyzed using Neo4j. Finally, we do the result interpretation.
For the solution, we propose RACE, which stands for Real Account Identification for Social Environment. RACE is a classification model which aims to pop out the real human from the huge gambling network. We use features such as degree centrality, betweenness centrality, closeness centrality, and eigenvector centrality of each interaction, follow, like, share, love, and comment. We later determine relationship between entities and use machine learning model to find out the real spot. With the 90% of F1 score of race, we need to interpret the result from the model. The graph demonstrates one of the features, which is follower betweenness centrality. The insight shows that entity which has more followers will be likely to be the real human. Realistically, we as humans need to interact, right? Then, this makes sense because real humans naturally interact and build social connections. Accounts with more followers often have higher betweenness centrality, making them key connectors in a network. Interaction features become a powerful tool to focus on the genuine accounts in large networks, which we will show in the next slides.
For the visualization, we use Neo4j to visualize and analyze our result by creating the network graph which show the interaction between users. This is example highlight the difference between humans and bot nodes. Human users typically have more follow interactions, reflecting the organic relationship, whereas bot users engage less in following but show higher activity in like and comments. Note that these patterns are valid only for this synthetic data set we analyze and may vary with different data set influenced by different in bot type and trends.
This succession page, based on the two-dimensional graph, the x-axis represents the number of activities such as comment, like, share, and follow, while the y-axis represent the friends or followers. Users are divided into three groups, distinguished by different colors. The dashed line indicates the probability trend between bot users and real human users as a linear function. The more activities and followers a user has, the higher of the likelihood they are a real human user, whereas bot users exhibit the opposite trend. The user groups classified by color exhibit distinct actions as follows. First, the abandoned group. This group added to a list for no immediate actions. Next, the monitor group. This group is monitored or placed under observation. Next, the take action groups. This group is reported to authorities for further action. In this summary page, motivated by the widespread promotion of gambling websites on social media platforms like Facebook, we sought to reduce such advertisements by employing graph network analysis. This method allows us to identify and classify user accounts, which promoting gambling websites, distinguishing between real human users and bot users. The analysis results in 3 key conclusions as follows. First, compared to real human accounts, bot accounts typically engage more frequently and in higher volumes with other accounts in a one-way manner with no any previous context. Next, bot accounts generally have fewer friends or followers within the network compared to real human accounts. Next, identify accounts within the network that act as key distribution hubs for content promoting gambling websites. However, the results aim to provide actionable insights for relevant stakeholders to take further steps. In this, the next action page. Nonetheless, the next action classified into 2 groups. First, at temporal analysis. Add time-based features to monitor trends and identify sudden spikes in gambling-related activities. Second, time in feature engineering. Consider the time dimension during feature engineering to better reflect the dynamic behavior in social network analysis and improve model accuracy. And the last one is our team member page. And thank you for watching.